the next objective is the electrostatic force between 2 point charges kept at a distance d apart in a medium epsilon r equal to 6 is 0.3 Newton. The force between them at the same separation in vacuum is dash. Okay. So here we can go for the first word, electrostatic force. The electrostatic force is otherwise called Coulomb force. Coulomb force. Okay. So the positive, negative, positive, negative, positive. These are the point charges. These point charges are separated by a distance of r in air. Okay. First, these two charges, positive, negative, experiences a repulsive force. Then positive, negative, positive experiences a attractive force. That force was given by Coulomb, so it is called the Coulomb force. Okay. So these 2 point charges, the experiences the force. The force of attraction or repulsion between 2 point charges is directly proportional to product of the charges. That is the first statement. The second one, the force of attraction or repulsion is inversely proportional to square of the distance between them. The force of attraction or repulsion is directly proportional to product of the charges, and the force of attraction or repulsion is inversely proportional to square of the distance between them. Then we can combine these two. So F equal to K into Q1, Q2 by R square. So what is K? K is the force constant. That is K equal to 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0. So what is epsilon 0? That is permittivity of free space. Permittivity of free space. Then its value is 8.854 into 10 to the power minus 12 Coulomb squared per Newton per meter squared. Okay, so when we can rewrite the formula, that is F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R squared. Okay, now the positive, negative, positive, negative, positive, these point charges Q1 and Q2 are separated by a distance of r in air. Now for instead of air, it is replaced by a medium. Okay, do you get it now? So first we placed the air, now we replace the air by medium. So what is medium? Apart from the air, when we are placing any material, then it may be the medium. Now it experiences a force Fm equal to 1 by 4 pi epsilon into Q1, Q2 by R squared. Here, epsilon is the permittivity of medium. It's a permittivity of medium. Okay. So now we can divide these two. So F by Fm equal to. So when we divide these two, 1 by 4 pi epsilon 0 Q1, Q2 by R squared divided by 1 by 4 pi epsilon Q1, Q2 by R squared. Now it becomes reciprocal. So after cancellation, then F by Fm equal to epsilon by epsilon 0. So what is epsilon? Permittivity of medium. What is epsilon 0? Permittivity of free space. Now we are seeing the relation so that it can be taken as epsilon r. Epsilon r. So what is epsilon r? Relative permittivity. Relative permittivity. So now we can combine these two. Then it becomes F by Fm equal to epsilon r. Now epsilon by epsilon 0 equal to epsilon r. The division epsilon 0 goes to right side as multiplication. So epsilon equal to epsilon r times of epsilon 0. Like that, the division Fm goes to right side as multiplication. So F equal to epsilon R times of Fm. Okay. Here the epsilon R is always greater than 1. The epsilon R is always greater than 1. Then the F is greater than Fm. Okay. So how we can verify? So we can verify with the second objective. So electrostatic force between two point charges kept at a distance of d apart. So for instead of R, they used the word d. Or they may ask x. So whatever it may be. So distance means R, D, A, Y, whatever it may be. Okay. So apart in medium of epsilon R. So epsilon R is 6. So what is the first given? Epsilon R is 6. Is 0.3 Newton. So Newton. So we can find that force equal to 0.3 Newton. But here which word is given? Medium. So that we can say the force in the medium. Next, what is asked? Force between them at the same separation. So what is same separation? At the same D, the vacuum. So for instance of vacuum, they may use the word air. The force in air is 1. So this is the given. So by using this, we can relate the formula. Okay. So what is the formula? F equal to epsilon R times of Fm. What is epsilon R? 6. What is Fm? 0.3. So 6 into 0.3, that is 1.8, then F. So what is the unit of force? Unit of force is Newton. So here is that F is greater than Fm. Yes. So how we can say the 1.8 Newton is greater than 0.3 Newton. So by using that, we can say F is greater than Fm. Okay, do you get it now? So the force is a vector. Force is a vector. So how we can say force is a vector, or what is vector? The vector quantity has magnitude and direction. Magnitude and direction. So how we can say force is a vector quantity? So let us consider positive. So this one is Q1 and it may be Q2. These two charges separated by a distance of R. Now Q1 is the charge, experiences a force on Q2. So how we can say force on 2 by the first, force on second by the first. So from the first to the second, and the distance is taken as R12. On the other hand, the F2 experiences a force on first. So how we can say force on first by the second. So from here to here, the distance is R12. So now we are giving the direction. This one experiences a force on that one, or that one experiences a force on this one. So we are giving the direction, and it also has some magnitude. Now only see. So force in medium, 0.3. So what is 0.3? 0.3 is the magnitude. So it has magnitude and the direction. So force is a vector. Okay. So what is the expression for vector? So F12 vector equal to 1 by 4 pi epsilon 0 Q1 Q2 by 1 2. So what about the distance? R21 squared, R21 cap. Or otherwise, F21 equal to 1 by 4 pi epsilon 0 Q1 Q2 by R21. So it becomes R12 squared, R12 cap. So from here to here or here to that, the distance is R1 to R21. So R12 cap equal to minus R21 cap. So why we are putting the minus? Because they are acting in the opposite direction. So when you substitute that, then F12 vector equal to F21 vector. So both forces are equal but acting in the opposite direction. Acting in the opposite direction. So now we are giving the direction so that the force is a vector. Okay. So on the other hand, so when you are having a system of charges, 1, 2, 3, 4, 5, 6, 7, like that we are having system of charges. Then all the charges experiences a force, then that force is said to be dash sum. That may be the question. Okay. So let us consider Q1 is the charge and Q2 is the another charge. Q2 is the charge experiences a force on first one. So how we can say force on first by the second equal to 1 by 4 pi epsilon 0 Q1 Q2 by R21 squared R21 cap. Suppose Q3 is the charge experiences a force on Q1. So how we can say force on first by the third equal to 1 by 4 pi epsilon 0 Q1 Q3 by R31 squared R31 cap. So like that the system of charges goes up to n. So the nth charge experiences a force. So how we can say force on first by the nth charge, that is equal to 1 by 4 pi epsilon 0 Q1 Qn by Rn1 squared Rn1 cap. Okay. So now we can add F12 vector plus F13 vector up to F1n vector equal to. Now which can be taken as common? 1 by 4 pi epsilon 0 can be taken as common. Okay. So what about the remaining Q1, Q2 by R21 squared, R21 cap. Like that it goes up to nth term. Just see the left side. So F12 vector plus F13 vector up to F1. So what is the word? Vector sum of. Vector sum. So when we are having system of charges, all the charges experiences a force on the first one, then the net force or the total force is vector sum of all the forces. Vector sum of all the forces. Okay. Can you understand now? Do you have any doubts? Okay, fine.